our exploration of linear equations. And in this lesson, we're going to graph linear equations by plotting ordered pairs. We're going to find intercepts, which we previewed in the last video. We're going to graph equations of lines in standard form, as well as vertical and horizontal lines. And then we're going to talk about modeling data again. So to graph a linear equation by plotting pairs, there are an infinite number of ordered pairs on every line because every single place you could put a dot is a dot on the line. So what we do is we take this and we consider that we only need a couple of points to play connect the dots. And if you look at this graph, there are some that might be a little bit suspect. If you look, I've had students say, well, 3, 2 looks a little bit out of place. Well, let's plug it into the equation. 3 plus 2 times 2 equals 7. Is that true? It is. So even though it's kind of out here by itself, it's still an ordered pair that's a solution. Now, they all look like they lie on a straight line. Keep in mind, we are human, so sometimes our sketches may not be a perfect line. That doesn't mean it doesn't fall on the line. Just go ahead and double check. I don't need anyone getting graph paper out trying to draw these graphs. So we're just looking for an approximation, and as long as your point is a solution, you're good. So a line is giving us a picture. So sort of like when we did inequalities, the line graphs showed us the entire solution set. The same thing is true of a line in the coordinate plane. It's showing me every possible solution to the equation that has been graphed. And so if I take that and I play connect the dots, it's a little wobbly, but that is the graph of a line. And so this process is what we call graphing. If I want to graph x plus y equals 2, I need at least 2 points. The 2 easiest points to find in any equation are going to be the intercepts. So to find the intercepts, I'm going to replace x with 0, and that would be my y-intercept. I would replace y with 0, and that would be my x-intercept. So if I'm replacing, I get -2 for y, which is the point, 0, -2. Then I replace and I get x equals 2, which I plugged in 0, so that's why the y value is 0. I have 2 points. If I wanted to find a third ordered pair, maybe I just want to be sure about things, I'm going to replace x with 1. Why do I do this? I don't have to. I'm just checking my work. So I get -1. So now I have 3 ordered pairs just to kind of check and make sure they do fall on the line. So I'm going to plot those 3 points, and it looks like they all line up. So I know I didn't make a mistake. So that third point is not necessary, but it's just kind of a self-check. So if I want to graph 5x plus 2y equals -10, the easiest points to plug in are 0. So I'm going to plug in 0, I get y is -5. There's my point. I plug in 0 for y, I get x equals -2. Remember, those are our intercepts. It's going to be important later. Then I just pick a third point. Just pick something to see if it works out nicely. I get y equals 5, so now I have 3 points. If they all 3 line up, it's a pretty good indicator that I did the question correctly. And they do. So there's my graph. Now, the intercepts, we've been talking about this. Our x-intercept is when the y is going to be 0. Our y-intercept is when the x is going to be 0. The most common mistake that happens is you get that mixed up. So people think x-intercept, x has to be 0. It's opposites. So if it's the x-intercept, the y value has to be 0. If it's the y-intercept, the x value has to be 0. On the graph, we call these intercepts because that is where it crosses the axis. So the x-intercept is where the line crosses the x-axis, and the same thing is true for the y-intercept. So if I want to find the intercept, I'm not doing anything new. I'm doing exactly what I did before. I'm replacing x with 0, I'm replacing y with 0, and then I'm finding that third point. It's not required that you find a third point. It's just a best practice. I'm going to plot my intercepts. That third point's there just as a self-check. And we're good. Now this one, it's in a little bit different of a form, right? Yeah, we see the fraction, we have a moment. But if I plug in 0 for x, I really shouldn't be stressed because it gets rid of that fraction. But when I plug in 0 for y, I get 2 equals 2/3 x. How do I get rid of that? Well, I can multiply both sides by 3, which would give me 6 equals 2x. Then I would divide by 2. So I would get 2 equals 3 equals x, because 6 divided by 2 is 3. So if you need a little bit of help from the Web 2.0 calculator, you can utilize it. It can't solve the equation for you, but it can help you a little with that fraction math. And then I'm going to pick 6. You can type this entire equation straight into the Web 2.0 calculator, and you get your third point. Do you have to find a third point? No. I plot my points, I connect my dots, and it's that simple. Now, the great thing about this equation being in standard form is it makes it very easy to find the intercepts. That's the whole benefit of using this form of an equation of a line, is that it's easy to find those intercepts, because if I plug in 0 for x, it just kind of works out nicely, right? I get negative 2y equals 0. Y equals 0. If I plug in 0 for y, I get x equals 0. I'm at the origin. But notice you don't have to actually solve anything to find x or y here. So that's why this form, standard form, is so very useful, because it does a great job of finding the x-intercepts. Now when you start plugging in other values, you have to do a little solving. But the intercepts are definitely nicer to plug in here. And then I just graph my intercepts. Now, why did I find additional points? Why did I go? Because my intercept was at 0 for both, and I need at least 2 points to draw a line. So that's the benefit of choosing 2, 4, and 1, 2. So if it goes through the origin, that means both of those are going to be 0, and you might need an extra point. Now I'm going to look at my vertical and horizontal lines. The graph of y equals negative 5 is going to be a line that goes across everywhere y can be negative 5. So here's my dot, there's my multiple dots, and it's a horizontal line. Anytime you have y equals a number with no variable, it's going to be a horizontal line at that number. Now, if I have x equals a number, this is different. X minus 2 equals 0. If I add 2 to both sides, I get x equals 2. So what do you think is going to happen? That was a horizontal line. This is going to be a vertical line. And it's a vertical line at x equals 2. Again, where do we make mistakes with this? The most common mistakes are going to be the ones that are made with getting this confused. Students will think x equals 2 is a horizontal line because the x-axis is horizontal. It's not true. It's opposites, opposites, opposites. So if it's x equals a number, it's a vertical line at that number. So horizontal lines are going to be y equals the number. Vertical lines are going to be x equals the number. Notice there's only one variable in these. So that's a great way to know when you're going to utilize this. And if we're using linear equations to model data, what does that mean? It means we just put it in a word problem. That's all we did. We put words around this. And if I want to know what is this like when it's in 2005, all I'm doing is saying x equals 5. And so I'm going to go on my graph to x equals 5, and I know that my time is going to be 14 hours, which is a lot of time. So when you're modeling data, don't get stressed out. You're just plugging into the equation, so you're just identifying what value do I plug into the equation. So x equals 0 represents 2000, 1 is 2001. That's how I knew x would be 5 for 2005. But all we're doing is what we've been doing, but just putting words around it. So I can plug 5 in for x and I get 13.9 out, which is roughly 14. So I can either use the graph or I can use the equation to get there.